All right. Well, good evening and welcome to the May meeting of the St. Louis Java User Group. We are 1 week off our normal cadence. We're normally the second Thursday of each month. This month we pushed that out by a week to work around some conflicts, but normally that will be our regular meeting time. So glad you're all here. If you haven't already, please help yourself to some pizza, and there are beverages, by the way, in the mini fridge over there under the microwave. So feel free to help yourselves to those. This is all courtesy of Object Computing, who also provides the space that we're meeting in tonight, and is also my employer, full disclosure. Good folks. All right. So I won't run through all the history here, but the St. Louis Java User Group has been around for a good long while. Maybe kind of start thinking about our 30-year anniversary, Bruce? Is that about right? Am I doing the mental math correctly here? Yeah, so typically we have food and just networking at 6 o'clock, 6:30 or close to it is when we begin the program. And usually things wrap up here around 7:30 to 8, depending on how long the discussion goes. And with Jim speaking, I expect we'll have lots of good discussion. So that'll be great. And normally we meet here in the OCI training room. And if you're here, you found it. So congratulations. All right, this is the steering committee. I am on the far right there. And the other members include Bruce Alspa and Ted Doyle, who are both remote out of Columbia, and then Robert Levitt, who's here in the front row. Sorry, Robert, I had to interrupt you mid-bite of pizza. You can reach all of us at the Google Groups address there at the bottom of the slide, and we'll share that again towards the end of the program. We'd like to thank our sponsors. OCI, I've already mentioned, sponsors the food tonight. They usually come in handy if we don't have another sponsor lined up for the food for the evening. And of course, they provide the training space. And then Manning and JetBrains are both longstanding JUG sponsors. We're very appreciative of them. And then our friend Lee Bobbitt has been sponsoring our meetup subscription. We greatly appreciate it. So thank you, Lee. As part of Manning's sponsorship, they give us a ongoing discount code for all of our members for any Manning ebook. And by member, if you're here, if you're seeing that code, you are a member. So congratulations. You can take 45% off your Manning purchase. That code is STJUG45, in case you're writing that down. Our presentation schedule. So next month, we have a presentation by Karthik Kathari on model context protocol, so MCP. That should be good. And then August 13th, James Fredley will be coming in town out of, I believe it's in Raleigh, North Carolina, if I recall correctly. And he's going to be giving us it looks like the presentation title might have been truncated there because I believe it's Apache Grails 8 along with something agentic. There's some AI in every presentation, it seems, lately. Any AI in your talk? Oh, okay. See, he's just gonna make me a liar here. All right. It does sound cool. Oops, I skipped something. Upcoming presentations. Okay, so check out our meetup.com page. I trust you've already found that if you're here. But that's where you can get updates for our future meetings. You can view past presentations on YouTube at the YouTube channel there, up on the slide at Bruce Alspa's YouTube. And if you are interested in giving a presentation or sponsoring or participating in any way with regards to the St. Louis Java User Group, please reach out at javasigsc@googlegroups.com. We're especially interested in finding folks who might be willing to perhaps serve on the steering committee. Because we only have a couple of us who are actually here in St. Louis. We would appreciate some backup. And if you're interested in that or have questions about what that entails, feel free to talk to me afterwards. Be happy to share more about what's going on there. All right, without more ado, tonight's presentation, The Past, Present, and Future of Software Quality by Jim Cakalic. Did I say that right? Cakalic of MasterCard. Oh, Robert, please. Can you mute your laptop?
I turned it off just now.
Hang on.
Wait a second.
There we go. That's not it.
Looks like it's off now.
Is it off now? Okay, sorry about that. Trying to operate somebody else's keyboard upside down. All right. We do it all here. All right. So with that, to our speaker, Jim, thank you. And I'll let you switch over your slides. Bruce or Ted, can one of you confirm that you can hear Jim?
Yeah, I can hear you. Your sound is pretty weak there, Jim. I can just
Yeah, let's take a pause here. Really sorry, Jim. It looks like your mic is not on for some reasons. It's not your fault. I'm trying to figure this out right now because you should be on wireless one, and for some reason, very sorry about this. Looks like you're getting picked up on this mic. Hold on. So let's see if I can figure out real quick here. This is the wireless transmitter. Yeah, this is that's the microphone. Yeah. Oh, because I'm used. That would not work. No, but see, you should be coming here over wireless one, and we're getting nothing on wireless one. Anything muted? Okay, I'm really sorry, but I might need you just to hang on to this. That's okay. So sorry.
I'm wireless mic resistant.
Okay.
This must be the interference level of my personality.
That must be yes. We'll blame that.
So now I got cards, I got a mic, and I got to operate the slides with my third hand. So by the end of the night, I hope to have convinced you that quality isn't a destination. It is a continuous enemy search for victims. With that, I'm going to tell you a little bit about my perspective. I won't read my resume to you. Suffice to say that I've been doing this for a while, and in various roles as both a delivery engineer and as an architect. Most recently, my role was at Spectrum, where I was a test architect. I've moved on from there to MasterCard. But I tell you that because in that role, I can honestly say I learned a lot that I didn't expect to learn, specifically about software quality that inspired me to write this presentation. And so I hope to share with you some of the insights that I got while I was in that role and see how you might be able to apply them in your work as well. So briefly, this is what we're going to cover. A lot of what's, whys, where's, how's. If I were to go around the room right now and ask everyone, what is your opinion? What is software quality? I'm not going to do that, but I will guarantee you that every single person will have a different answer. And from that, you could take possibly that quality is subjective. And that might be true, but it's also objective. What is really subjective is people's ideas or values as it comes to software quality. So here are just three perspectives that are common to our experience. We have the user perspective. They're going to be concerned most about, does it do what I want it to do, right? Is it functionally correct? Is it usable? Is it reliable? Is it accessible, right? Those are things that a user cares about. But then if you ask the business owners who are developing this software, well, is it worth, they're going to ask, is it worth the investment? I mean, how much am I paying for it? Am I getting the value out of it? Is it secure? Is it compliant? Last thing they want is to break some regulation in a regulated industry that then causes them to have to pay fines or even go to jail. So those are a different set of questions, but they're also quality questions. And finally, from these three perspectives is the perspective most of us probably share, which is that of a developer. Can we change it later? We're looking at the code. Is it maintainable? Is it testable? Is it portable? Right? Those are the kind of questions that may fill our minds as we're thinking about what is software quality. And the important thing to realize is that none of those are wrong, but none of those are completely correct, right? They all leave something out because all of that is software quality. The 10% of this iceberg, the 10% at the top is what most people think of when you ask them about quality. Does it do the right thing, right? And that's extremely important. I mean, let's not discount that. But as the pilot of the Titanic learned, the part below the water is also really important. And it can sink you if you don't pay attention to it. And that's where 90% of what I call the implicit quality exists. Security, performance, compatibility, reliability, maintainability. Those are the kinds of concerns that vibe coders typically aren't thinking about. They're thinking about the functional perspective. Was I able to build something quickly that seems to solve the problem? But then getting it from having solved the problem to, can I support it, right? Can it live somewhere that I need it to live? Can other people access it? those are different kinds of questions that aren't answered quickly by the current set of vibe coders that we have claiming lots of success around I LLM my way to software. So with your permission, I'd like to leave the vibe coding zone, and we're going to enter the engineering zone. The ISO, or International Standards Organization, is a governing body that creates standards around products and processes, including software, that ensure that they're more reliable, globally compatible, and safer. ISO 25010 is one of those standards that they produce, which lays out a software quality model. And I appreciate, and I apologize, when you see the slides, you'll get a better idea of what all these things are. But ISO in their model lays out, I think it's 9 quality characteristics. Okay, of them, there's like flexibility, portability, maintainability, compatibility, efficiency. This pie slice right here is functionality. That is the only one that's concerned with what the software actually does from the perspective of its requirements. Yet that's where most of us have been trained to focus, right? We've been trained that this is everything. If it doesn't do it right, yeah, it's a part above the water, exactly. But look how much of the pie isn't in that part. ISO then breaks that down into all these sub-characteristics. We just blow that up a little bit. I'm still probably not going to be that readable. Okay, but here's the functionality again. And that breaks that down into appropriateness, correctness, completeness. We spin around here over to reliability. We're looking at maturity, availability, fault tolerance, recoverability. All those are sub-characteristics of that quality model. And they're all things that we as software engineers and delivery organizations need to be concerned about. One more thing that I've added to this wheel is that now in this final outer ring are all the kinds of ways that you can go about testing for those particular characteristics and sub-characteristics. So again, we look at something like functional correctness. You have user acceptance testing, regression testing, and unit testing. You spin around to something like compatibility. Then interoperability, coexistence is contract testing, integration testing, API testing, conflict testing. Now, you can ask me what all those are. I probably can't tell you what every single one of them is, right? So I'm admitting that there's a lot of it I've got to learn yet here. But I hope to show you, if nothing else, that the picture is much bigger than this. And all the things that go into software quality require us to know and do and learn more than just this. We need to do all of this. Now, it comes in varying amounts, which is what the perspectives tell us. Because the user cares about this part, right? Developers care about this part. Business cares maybe about this part. Other people are going to care about other parts, right? Your DevOps team is going to look at this. I mean, their whole job is around performance and efficiency, right? They care, does it run, fast enough to handle the load? Am I constantly tracking down problems? So all of these are important aspects, and our job as quality engineers, if we want to put it that way, is to understand how important they are in our environment so that we can balance the level of attention that we give to each one of those. Because it's going to change from company to company and even from day to day within the same company. Different things are going to be important. I'm not going to spend a lot of time defending this particular slide. This is called, I think it's called the beam curve. And it comes out of some studies that were done in the late 70s. It's not meant to be taken exactly literally. I mean, everybody's going to argue over, is it really 100 times more costly to find a defect in testing as it was to find it in requirements? I don't want to have that argument. What I want you to focus on here, and what this is trying to visualize is, there is more cost along the way. And a good way to think about that is, you're baking a cake. Requirements phase is when you're reading the recipe. If you are reading the recipe and you see that it calls for salt, you stop and say, well, wait a second, there's no salt in cakes. Something's wrong here. I've got to fix that. What's the cost to fix that? Get your pen out, cross it out, right? Very, very cheap. But now, let's say you've moved on from there, you're in the development phase of your baking. You're creating your mise en place. You're pulling all the ingredients out, getting them all together. And you pulled out the salt because you didn't catch it in the requirements phase, and it's open, sitting next to the flour. And that's when you realize, oh, wait a second, that salt could spill into the flour, and then I'd be in trouble. So now you caught that in development. Well, it's a little bit more expensive because you pulled it out. You got to pick it up and put it away, but not a huge amount more expensive, right? Well, now you mixed all the ingredients, and you're starting to taste the batter, and the batter is really salty. Well, now it's harder to recover. I mean, at that point, you wasted your ingredients. You got to throw away that batch, clean your pans, make another batch. Okay, so it gets costlier as you go to correct that mistake. Get into production, you're actually baking the cake, and you smell it. It's baking in the oven, you realize that shouldn't smell like the ocean, right? Well, now it's even costlier because now it's probably burnt. His salt will burn like that. So now you're going to have to pull it out, cool it down, scrub your pans, go all the way to the beginning, get your ingredients, make another batch, get it in the oven. So costs add up. But what if you don't catch it until the night of the party when you serve the cake? Now we're talking about a whole different kind of cost. Now we're talking about a reputational cost. You ever had a dinner party where something went wrong? How long did it take before your friends stopped talking about it? If they ever did, right? Maybe they're joking with you about it to this day. Well, in business, they don't joke about it. Your reputation can cost you everything. And so if you don't catch something in a defect in the system that you're building before it hits production, you can lose customers at a bare minimum, right? That's money that the business has lost. Very, very difficult to recover from that. Another concern that we have to deal with why quality is so important is the operational issues. It determines whether you're going to go home tonight or whether you're going to be up until 2 in the morning trying to fix a production problem. If you've ever been on call, you know how that is. And every time it happens, you tell yourself, I need to do something about that. And then you go to bed, come in the next day, and it happens again. So reliability, concerns like scalability, stability, security, compliance, observability, predictability, right? Those are all operational concerns. That's all about whether you can keep the systems that manage your business available for your customers to use. So how do we get here? I mean, just very quickly, you know, when we first started writing software, probably was all manual, just that's it. Not probably, I know it was all manual. My dad was a programmer in the late 50s, early 60s. And so it was all desk checking, print out, you know, reams of paper, walk through line by line, you know, making corrections. We got into the waterfall era. If you've ever heard of the V model for software quality, yeah, I know you have, Steve, because we live this in the biomedical regulated industry. But the V model preaches verification and validation. But unfortunately, where it puts waterfall, unfortunately, being a bad name for the process that should have never been that, it puts quality at the end. It says it's the last phase. We're not going to even worry about it until we get there, right? We're going to build the whole thing, all that cost baked in now, and just before we serve the cake, that's where we're going to see where we went wrong. And of course, the problem there is whatever you put last is the thing that you're probably going to cut when your budget or your time runs out. And we've all been on projects where the budget and or the time ran out. And you know that the last thing that happens before you go to production is the testing. And they're always wanting to squeeze that testing down to the minimum necessary to roll it out because they got to make it 8, got to make it 8. Okay. So these are lessons that we've learned about software quality along the way, right? Desk checking by itself doesn't work. Static analysis is good. Code review is good, right? But it doesn't solve all the problems because we can't, with any program of any reasonable complexity, you cannot hold the whole thing in your head. So you can never desk check something completely to ensure that it is always going to satisfy all of the quality concerns that you care about. So static checking is good. Dynamic testing is a good complement to that. Not better. I almost said better. I meant a complement. The two together are better. And the V model recognized that. But as we moved on, we learned we can't just wait until the end. We have to shift left, right? We have to pool those quality activities earlier into the process. We got to have better requirements verification. As we go through architectures and designs, we have to challenge them. Are they really going to meet the quality aspects that we care about? And this is one of the things I've learned about architecture over the years, is that architecture is all about understanding your constraints and balancing those constraints, which again are going to change from project to project, almost from day to day sometimes. And if you don't understand those constraints, you'll never be able to produce a quality product. You'll always be missing something along the way. It might be functionally correct, but not scalable. Might not be usable, right? Might not be resilient in some way. So you have to understand which of those are important and balance them. And Agile was about learning those lessons and trying to apply them with this process of shift left. And now, where are we? Here's your AI. now we're automating, but now we're going to also start leaning on artificial intelligence to help us in that automation. Not just by running the tests we already wrote, but by creating the tests, by keeping the tests clean, right? And in other ways that we're going to learn about as we start applying this technology. But this is the autonomous QA era that we're entering, and this is where it gets exciting. No talk on quality would be complete without the pyramid. We always have to talk about the test pyramid. Yes, sir. Yes, sir. And we'll get, I took some slides out, but I think we'll get to that a little bit more. The testing pyramid is supposed to help us envision how much of each kind of testing we need, right? As well as understand what it's going to cost us and how fragile that testing might be. So base of your pyramid, unit tests. Those are low-level code tests. Obviously, we all know that, right? They tell us something about our code, right? But not very much, because we're only testing small things in isolation. It isn't until you've tested the engine and the drivetrain together that you know that's actually going to drive the car. That's when we start putting these pieces together. You might have component tests. We actually have assembled an entire microservice from all of its bits. And we're going to test it at the edge now with API, And we're going to put mocks in place so we can test it in isolation without all of its other dependencies. Up the pyramid are integration tests. Maybe that's multiple microservices or multiple small pieces of a system working together. User interface tests. Got to have them, right? Because user interface is where people interact with our system. And then end-to-end tests are across the enterprise. But the point is, as you go up, the cost of writing those tests goes up, right? Because you have to know more, you have to integrate more things. The brittleness goes up because they're more likely to break. I mean, how often have you been in the case where somebody renamed an HTML element and all your tests broke because they couldn't find the submit button anymore? But then we also have to realize the effectiveness also goes up as we climb the pyramid, because we're covering larger parts of the system. It tells us more about, does everything work together to accomplish the goal? But it tells us less about what's going wrong when something's broken. Right? Unit tests tell us a lot about that. When something breaks, boom, we know it right away. That's why we value them. If you've got a user interface test, common quote that I remember in a book on object-oriented testing from 20 years ago, I think Binder was the name of the author, is that trying to test any system through its user interface is like trying to pick up a dime with boxing gloves on. You just don't have the ability to do things at the user interface to figure out when there's problems, where that problem is actually occurring. You might be able to make intelligent guesses about what you know about the system, but it's not pointing you in a particular direction. Here, using unit test, you know exactly where it is. With an API test on a microservice, you know which path is causing the problem, right? Integration tests, a little bit harder to figure out because now you got lots of things working together. What's going wrong? You got A calling B, calling C, calling D. Which one is the problem? So as you can see that the effectiveness goes up, cost goes up. What it tells you about the system is better, but it's also less precise. Most of your tests, as the volume arrow shows, should be towards the bottom of the pyramid. You should have lots of unit tests and a few end-to-end tests. Okay. You need them both, but it's the volume that's concerned. And then you have your cross-cutting non-functional tests. What do I mean by that? How do you test load? How do you test scalability? Right? So those kinds of cross-cutting concerns that require you to have the whole thing together and apply a special kind of testing to it to see if it can actually accommodate, 100,000 users at once, simultaneously banging on the enter key. All the other kinds of testing don't really tell you that. So you've got lots of different kinds of testing, and all of this is to help us sort of picture in our minds how we're going to approach that. Because I can't tell you, unless we're working on something together and I know a lot more about it, how many unit tests you should have. Maybe you should have 10, maybe you should have 1,000. Or how many user interface tests you should have. Right? So it's going to vary how much of this you need. But this is sort of the general shape of what your test should look like. Ugh. Get ahead of myself here. So this is to help us understand that quality starts with a conversation. If we're really shifting left and we're trying to figure out how to prevent defects, not just detect and fix them at the end, okay, then the conversations about quality really start with the requirements. Product owner or someone in the business has an idea, they express that idea. We got the developer here. Our job is almost always thinking about, well, how am I going to do that? They want an anti-gravity component. How am I going to build that? Is this even possible? Right? That's why you need this other person in the room. The quality engineer is always asking the question, how are you going to prove that? How are you going to test that? How are we going to know it actually works? What do you call acceptable? Right? That's the perspective that we need always there, challenging us to answer questions about how is this going to be a quality deliverable. And so all three of these people have a conversation. And in the light bulb, you see given, when, then, which is a call out to basically the structure of what's called behavior-driven development. It says, express those requirements, especially acceptance criteria, as scenarios. Given the state of the system is in a certain place, right? When something happens, then the system should respond this way. Right? So if you say something like, given a user has registered in the system, when that user logs, presents their user ID and password, then the system allows them to authenticate and shows them their home page. Right? It could be simple as that. Obviously, they're going to get much more complicated than that as you break your stories down and dive into them. But the conversation has to happen. It's the conversation that's important, because if the conversation doesn't happen, then nobody's talking about quality until it's too late. And the reality, of course, is that that conversation in business terms has to be translated into technical terms, which is always going to be at least one, usually more than one path. Because most systems, modern systems, present two interfaces, one for humans and one for other systems. And so you have to think about how, given a set of acceptance criteria, like the one that you see here, given an account with $1,000, when I transfer 200, then my balance is 800. There's likely going to be something that you have to do to orchestrate that in the user interface, right? And then there's likely something that you have to do in order to be able to accept that transaction across the wire from a partner. Both of those need to be tested. And how those are tested are going to be very different at the technical level. But they need to trace back to this original acceptance criteria that the business said, this is what I call acceptable. This is what I call functioning. And BDD is one way of doing that. If you have tooling that allows you to take that same kind of structure from the business requirement, your user story, and carry it into the actual executable tests that you're running, and they have the same sort of structure, you can trace back to that requirement, then that gives you the ability to then easily translate these and maybe even automatically translate these into the kinds of functional tests that you need to be able to execute. I kind of spoke through that again. But this is a concrete example of that. I'm sorry if it's hard to see. Let me see if I can blow it up a little bit for you. I'll take this side. So again, a business intent expressed as a user story is what the business says. From my perspective, this is what the system should do, right? Here's your acceptance criteria. From the user interface side, it's going to look a little bit different, right? But basically, it is how you would orchestrate this using a tool called Selenium that would provide these values to a browser and orchestrate the browser interface. But you want that traceability back, so you know that you have functioning tests that tie back to the acceptance criteria that the business originally established. And again, the idea is that if you can have a way of expressing both similarly, not identically, but similarly, that helps in solving that problem of traceability. So I just spoke about Selenium. Selenium's UI side of what's been generally come to be used predominantly on the UI side now to orchestrate a browser. So you can find elements on the page, you can fill those elements, you can select radio boxes and check boxes, you can pick from lists, you can click links, click buttons, and you can automate all of that so that you have a repeated test against the user interface. Unfortunately, on the system testing side, we've got a little bit more of a mess, right? We've got all these different technologies. We've got to try to bring them together somehow. We've got different tools across those technologies. It's not very clean. It's not very orderly. Wouldn't it be wonderful if we had a universal adapter, something that we could do everything in, right? And we cover both the human side and the system side, including all of those technologies that we generally care about. Karate, Steve, is one of those universal adapters. Its whole goal is to bring all that together into a common execution environment using the given when then BDD style of expressing tests in order to create executable tests that let you do all of these things across lots of different technologies. Another one that I've worked with in the past that I don't have up here is called the Citrus framework. Citrus framework helps you do the same thing. Lots of different technologies, express your tests primarily as BDD, given when then, technology specific, of course, because if you're calling an API and the request body and the response body are both in JSON, you got to express the JSON somehow, right? So they're going to be technology oriented, okay, but they follow a common style, and one engine that can execute all of them and can execute them together. So maybe you have something that starts at the UI, right, does something, and then comes back behind on an API, does something, goes out and grabs a file from somewhere that came from the mainframe, does something, and all that's part of one test, right? Now you have a really strong tool that you can use across all of the domains you need to test around and all the technologies you need to integrate. So these are the kind of tools that are going to make your life in testing much easier. Originally, Karate started out as a unit test only kind of tool. But since then, they've been building it, and I've been using it my last gig actually at Spectrum with quality engineering teams that had no development background at all. They don't have to know how to open an IDE. They don't have to know how to write Java or JavaScript, right? All that we took care of behind the scenes. So all they have to do is write the given when then that express the tests that they care about. So the cognitive load on your testers comes way down. The amount of experience they have to have as developers comes way down. So those are the kind of tools you want to look for so that you can orient the entire organization towards quality processes, not just developers, right? Developers, we do expect them to do a lot. We do expect them to write unit tests, right? That's their job. But then other perspectives come in and say, I'm going to make sure that these things are really working together properly. And we need to provide tooling so that they can do that. Say again? I found it's been pretty effective at that. Yes. Bobby, I mean, if you have experiences, you want to kick in on that, we've worked together on those things. Yeah. I mean, it's not magic, obviously, right? But karate takes you further down the road than a lot of other tools do. Citrus framework, similar that I mentioned earlier, takes you pretty far down the road in terms of integrating those technologies, making them cohesive in terms of your testing ability. And the whole point is this: democratizing automation. Right now, if you got there's a bar. Right? If you have to have development skills, there's no democracy there. You have to turn to your developers or quality engineers that have a strong development background, which not a lot of them do, right? You have to turn to them to help you automate. But using other tools like karate or Citrus framework, we have the opportunity to bring other people into the picture, not just developers, but testers, quality engineers, QA analysts can express those tests, and maybe they can only get 50% of the way down the road before they have to give to somebody else who understands more. Maybe who understands HTML deeper, or JSON deeper, or XML deeper, right? But they can now be involved in that process as opposed to being excluded from the process. And from our perspective, the more people we can get involved in that process, the better. We want everybody to be thinking about quality all the time, because without that, what does it matter? So how do we evaluate? Well, we've almost been trained as developers to think of one metric and one metric only. Who knows what that is? You can see on the slide. Unit test coverage, right? We taught, look at your line coverage, look at your branch coverage, look at your path coverage, get everything as high as possible. 100% is great, right? No, not so much. Because first of all, what do unit tests focus on? Almost exclusively functionality, right? They tell you whether the code in the small or in small aggregates is doing what you expect it to do from a functional perspective. There are other kinds of unit tests that you can write, which are benchmark tests. So perhaps some of you use the Java microharness benchmark framework. But that's a framework that lets you write, it says micro benchmarks, which are around small bits of code that usually are hard to test in the context of a JVM because there's so much JVM noise, right? There's all the class loading at startup. There's the JIT warming up and compiling, and the numbers change. There's garbage collection happening. All that is noise that gets in the way of you really understanding what this little bit of code here, maybe just one or two lines of code, are doing. Like think of it, how do you write benchmarks around string concatenation? I had this problem when I was working for Bobby out at Charter. It was sort of a coding challenge that came up in the groups that were working. It's like, first of all, how many ways are there to concatenate a string in Java? And I came up with like 9 or 10 different ways to concatenate strings in Java. And then which of them is faster? As if that's the most important thing. Well, benchmarks tell you that. Micro benchmarks help you figure that out. Because if you do it the wrong way, you write a string concatenation in a loop and you throw away the result. The JVM knows enough to throw away that, not even execute that code. Because that code has no side effects, it has no value. So when it comes in and compiles that and optimizes it, it says that loop's doing nothing. I don't even need to run that loop. And so your benchmarks might be like this, okay? But that doesn't tell you what it's really doing. So there's so much to know and think about when you're trying to write small benchmarks like that. JMH helps abstract that away so that you don't have to know all of that. It encapsulates that for you. So you get much more accurate, small code, maybe even just single method benchmarks. But beyond that, still unit testing is almost all about functionality. It gives us an illusion of quality. It gives us a number we can point at. And unit tests are they're easy to fake too, right? I can get 100% code coverage today on any code base you give me. You know how I'll do it? I'll write a bunch of unit tests that don't assert anything. They call all the methods assert nothing. I got 100% code coverage today. Tells me nothing about the quality of the code. Okay? And that extends further. How do you know you actually have good unit tests? That's a whole another talk. And we'll be arguing about that for another decade, at least. Yes, sir. Right. Yeah, there have actually been whole frameworks written to test getters and setters. So that's all it does. You basically point at your class, you point at a whole package, and it'll figure out where all the getters and setters are and run tests that exercise all those getters and setters without you writing a single line of additional code, just so that you can get to that 100%, right? Or get from 60% to 80% or whatever the goal is. What is that? The Goodstone's law, something like that. I'll have to look it up. Who basically says that whenever I quoted this to you the other day, Bobby, whenever a metric becomes a target, it ceases to be a metric. So if your target is 100% code coverage, it's no longer a metric of how good your code is, because we'll do anything we have to do to get to that point. And even if we're ethical about it, right? And I assume let's assume everybody wants to do the right thing. It's really hard to get to that 100%, really hard, especially if you didn't design the code to be testable in the first place. And that level of effort for the minimal amount that it gives you in terms of what unit tests offer means that we're not paying attention to the other things which are equally important. But what is that? Things like structural code, so structural health. When we look at our code, what other kinds of metrics can we find? Cyclomatic complexity. That one's been around for years. McCabe introduced that decades ago. Tells us how complex the code is based on how many branches are possible through it, right? Cognitive complexity is a new one that Sonar came up with recently. Tells us basically how hard is it for a developer to read and understand that code. We got the level of cohesion within the class. It's funny, one is this actually measures the lack of cohesion. So you have to invert the measure, but the idea is in any well-factored object-oriented program, at the ideal state, not even the possible, probable, but the ideal state is that all of the methods are about all of the data all the time. If you've got a method that's about some of the data, not all the data, that reduces your cohesion. If you have a class where you've got 9 methods and 3 of them are about this part of the data, 3 of them are about that part of the data, and 3 of them are about some different part of the data, you probably got 3 classes, right? Because that cohesion tells you that there's something wrong in the way that you decided to package your code. How many public methods per class? Here again, the ideal, 1. We'll call it constructor free. 1 public method, because that method, that class should do one thing, right? Single responsibility principle. I'm not saying do it. I've tried, and I don't like the code that comes out of that. 1 public method per class. So I'm not saying do it, but that's the ideal, right? And you want to minimally reduce the number of public methods, because that reduces the interface that class presents to the world, and also helps ensure that class is focused on fulfilling a single responsibility. Lines of code per method. One of my favorite. One of the first things I look at. If I open a class and I'm immediately staring at a wall of code that never ends, my heart breaks. It does, right? None of us want to see that. And when we look at that, we also then can almost guarantee that it probably doesn't have any tests, because nobody wants to write tests for that. It's just too much to look at. So lineups of code per method being low, one of my favorites. But these are all things you don't detect with unit tests, because unit tests aren't about any of this. But these are all quality aspects of your code. They're structural aspects. Well, what about some more? How about operational health, right? And these are really about measuring your testing process itself. So defect escape rate. This is one that we look at on QE teams. Defect escape rate basically says how many tests or how many defects did we miss? How many actually escaped into the wild and weren't found until they hit production? That tells us something about how good a job we're doing. You can never find 100%. Okay, we all know that you can't find 100% of the defects in any complex code, but we should be striving for as many as possible. And if defects are escaping, that tells us we've got a place in our process we might be able to improve. Test flakiness index. I mean, when you run your tests in the CI/CD pipeline, are there tests that like just randomly seem to fail, and you're chasing your tail because the build broke, and there's no obvious reason why the build broke? What do you usually do? You turn off that test, or even worse, you turn off all tests, right? Just to shut that one up. So flakiness is important. You don't want flaky tests, so you want to measure that. Mean time to detect basically says how long does it take us to figure out that something's going wrong, right? That we actually do have a defect. If it takes us a long time, that means that we have a larger potential blast radius. Right? The longer you have cockroaches breeding into your fridge, the more cockroaches are going to be to kill, or the more damage that they're going to do. So you want to find those defects quickly. And mean time to detect is a measure that helps us figure out how long did it take us once something was released into production to ultimately find it. And then the other related one is mean time to recover. This used to be called like mean time to repair, but that was too broad. So mean time to recover is focused really on those defects that got released to production, right? As part of this build, how long did it take us to recover from that defect? How far back in our process do we have to roll? Was it actually an architectural concern? Maybe it was a requirements issue. Maybe it was just a bad requirement, and two teams interpreted it differently, right? Mean time to recover is how long does it take us once we know we have a defect to come out of that? And these are process metrics. Again, unit tests aren't going to tell you anything about this, but they're important measures for understanding how well you are as a team at finding and preventing defects in your code. So where do we expect this is going to go in the future? Here's your AI section. Mandatory AI section is coming. If you don't want to hear it, you can leave the room. This is my visualization of what I think is happening. So much of the current generative AI focuses on making developers faster. But we also know that so much of what generative AI doesn't just mean faster produced code, it means poorer code. It means code that has security flaws, uses old versions of the library, focuses on the happy path and doesn't deal with exceptional paths. And so it has no recovery from them. It produces code that is good in the small, but not, because it's focused on narrowly solving a specific problem at a specific time in a specific set of code, not how that works across a larger system. Now, I'm not going to say AI is not going to get better. I'm sure that it will. Okay, but at least for now, we have this paradox where we're getting faster on spewing out more code, okay? And we have to get stronger at detecting the bad code, right? So we got to improve our governance in order to make sure that what we send to production is the goal that we want to produce. I call this the Rumpelstiltskin slide. Because we all have a lot of worthless straw being generated, and we got to turn it into gold somehow. Okay, that's going to be where quality engineering organizations are going to have their focus, at least over the next few years, in my opinion, trying to solve that set of problems. Right? We're going to go from manual testing, which is still done a lot, especially on the UI side. We've gone through into automated testing, but now we've had this whole field potentially of autonomous testing. So I've got a Swagger or an Open API doc for my API. Can I have generative AI actually generate the API tests for me? I don't want to write those tests. I want it to generate them from the spec. Or I've got a user interface, and I want it to be able to examine that user interface and figure out how to test that user interface for me. Or maybe self-healing, right? I've got user interface tests that assume the submit button or link has a certain HTML element name. When really what I would care about is that HTML element's role. And so what ways can we find to help us have our tests be self-healing, so that if a developer comes along and they change that HTML element's name because the test says I'm looking for something that operates as a submit role, I can still find that. It can heal that for us. These are the kind of opportunities we might see emerging in AI. Oops. But really, I mean, it's still going to be us. It's still going to be us operating the machine. If you're familiar at all with Greek theater, the Deus Ex Machina was when, at some point in the play, some unresolvable situation suddenly was resolved by a god being lowered into the scene and magically fixing it all. And if you read any of the AI hype, that's what we're being told is happening. Wasn't true then, it's not true now. We still need to be the ones that are in control. We are the oracles. And the oracle, as you know, is the source of truth, not Oracle, the database. And so we still have to remain the source of truth. I mean, we can have a greenhouse where we're growing all sorts of stuff, but we planted it. We're the ones that put it in. Think back to that API spec automated test generation I talked about a moment ago. What would you need to actually have it be able to generate API tests from a spec? And do you think that you're writing specs today that provide that detail? AI can't know just by looking at the spec, for example, what a valid value is in an account identifier field. You have to put that in. Does your spec have that? Does your spec have an example of a request and the expected response? Because that's what it would need. But that comes back to us, right? That's us understanding our systems and giving it the information it needs. Because just like any other computer system that's ever existed, garbage in, garbage out. So where I'm looking for in the future is that we become the new vanguard. Okay, we're not just developers cranking out code. Okay? We're not testers just writing scripts. Right? We're learning how to use AI to actually make us faster, better, stronger, the $6 million man of testing. Anybody remember that show? You're making me feel old now. So, that's okay. I'm sorry. I'm almost done. This is my last slide, Steve. Last one. So we spent a lot of time talking about pyramids, prompts, right? Pickles a little bit. Gherkin is the language that BDD uses, so that's the pickle part. I took that slide out, so my fault. But really, we're talking about an era when we're being told that essentially code is free, right? I'm sure we've all heard that said somewhere. Code is free now. We don't need developers anymore. And it might be that if your entire value proposition was I'm typing the code, maybe we don't need that anymore, right? I used to think that typing the code was all the joy. I mean, it was me being involved in the creative process, and I was writing stuff and solving problems. And I still like doing that. But as I started to use generative AI, I realized that wasn't the real source of my joy. My joy was in solving the problem. And if it helps me solve the problem faster, then I get that endorphin hit more often, right? So I actually enjoy it more. I have to be aware, though, of the problems, and that I'm the only one that will be able to see the problems in the code that gets generated. I have to be the source of truth, the sentinel of truth. And the quote that struck me as I was working through this before I actually wrote it down, because I would never be able to remember it, is, as the speed of delivery approaches infinity, the cost of a mistake approaches catastrophe. So the faster things get, the more aware we have to be of what we contribute and what role we play in the process. So that's what I had to tell you about software quality tonight. I hope that you have a different perspective now when you came in the door about what that involves and what role we can all play in it and what our future might be in that. Any questions? Thank you all for coming. Yes, sir. So I, right. So your question, if I can just summarize for the online audience, is primarily about what I would call test debt. Test debt, not tech debt, test debt. I just made that up just now. So, but to your point, you've got lots of tests you've built up over years. You have two problems, really. One of them is given a change, what is the scope of tests that I need to execute? And that's a classic problem in test strategy, right? The easy way out, of course, what you said, I just got to run all my 50,000 tests every time I change anything. Okay, but that's a very wasteful approach. I mean, this is what we were dealing with at Charter or Spectrum specifically, when any change to any of the 200 microservices required a full regression test on multiple user interfaces. And that was the accepted mode of operation. And what happens, obviously, is then you overload your QE organization. The joke in that shop is, I can say because I'm not there anymore, is that it takes us 2 weeks to make a change and 2 months to test it. Right? And that shouldn't be the way it is. We don't want our quality assurance practices to slow things down. Okay, so there's two things that I have in my head about what you said. One of them is definitely, Sam, unnecessarily. You're correct, because I also slow things down when I see risk. Okay, that's a valid reason for saying, put the brakes on this, let's reevaluate. In this case, if we're all executing lots of tests all the time unnecessarily, then we need to look at how do I, as you bring up a tool, evaluate what is the scope of testing that I need to do given a change. That requires a lot more knowledge about both your tests and your system, obviously, right? And if you don't know how those two things relate to each other, you're hard pressed to make that judgment. Okay, so that is sort of an issue around test hygiene. Okay, and test hygiene is two things. One is that idea of knowing what tests, a two-directional dependency, basically, how tests relate back to your requirements and how they relate to the code that was implemented. That traceability has to be part of what you practice as test hygiene as you build out that suite of tests that you're now executing every time you change code. The other is, if you're building this up over a 10, 15-year period, what's the probability that you're going to have a lot of duplication? Maybe some of those tests really don't stand on their own anymore. Maybe you should get rid of those. Instead of having 10,000 tests to run, you've got 5,000 tests to run. That's still a lot, but you could argue that by stripping it down, you've reduced your need to have as a stringent traceability. Not eliminated it, but reduced it, because now I can run 5,000 tests, arguably half the time to run 10,000. Okay, so those are the two things I would start to think about as I approach that problem. You know, if you would ask me tomorrow, you know, how can we solve this problem? Those are the two answers I would give you. They're not really answers, they're strategies. You're damned if you do, damned if you don't. Yeah. I mean, it's a different problem. And I would rather have the problem of having more tests than none at all. I mean, if you ask me which hell I prefer, that I would prefer the hell that has more tests. Right. And that traceability is hard. I'm not trying to dismiss it away. It's hard. And it takes discipline. But that's kind of the thing we've been missing. I mean, we call ourselves engineers, but do we build bridges this way? I wouldn't want to drive across a bridge that was built the way most of us build software. I'm sorry to have to say, you know, I'm part of the problem, right? Understood. Right. Harness, you said harness, right? Right. So there's another example where some form of generative AI likely is involved in building a history of what it meant to change that particular section of code, right? And then extrapolate from that what the tests were that were needed to actually verify it. Go ahead. Something else I've been working on from a static analysis perspective, and I don't think you've been to something yet for this, but is a tool that I've been writing in Go that is able to read the Java source code of a repository, build in a symbol table just like Java-C would, read bytecode, and add that to the symbol table, and detect all the places from a technology perspective where a thread of execution could start in the JVM, and then walk the call graph to figure out all the places where that application is emitting something. So it could be another REST call to a different service, across REST template or Feign client or raw HTTP client, or writes to an Oracle database using JDBC or JPA, something else, right? MySQL, calls out to a Mongo collection. And then from that knowledge, from visualizing, like you could start at a REST template, or not a REST template, you could start at a REST controller, for example. That method has, what does it call? Walk that graph out to find its dependencies, and then build from that a database of those dependencies. So that as I add to it, each time I analyze a different part of the code in the system, I create this connected graph of all those dependencies. So in a large microservices application, you would end up with a database that'll essentially let you trace from static analysis, calls from one end of the system to the other, see all the things maybe that touch this particular Oracle table, right? So you can start interrogating it for some of that blast radius. If I make this change over here, what are the more coarse-grained things that are affected, so that I can figure out what my test strategy is for performing that verification. A lot of fun actually writing that, but I don't know where you're done. Yeah. I will tell you that I spoke just this afternoon with a new developer at MasterCard, who someone introduced me to. She just graduated from school. We started talking about this, and she's like, "You're saying stuff nobody's ever said to me before." Okay, I don't know what school she went to. That's a good question. I mean, a new developer, I think it's highly environment dependent. Okay, there are some companies that are going whole into generative AI and actually announcing that they're not hiring any more junior developers because they don't need people to write code anymore. In that kind of environment, the Salesforce types, they won't survive at all because there's no environment for them to grow it. They can't plant, you can't plant them there and expect them to become a senior engineer if they're never going to get a chance to touch any. In other environments, and I'm thinking more about perhaps more government kinds of positions where they're saying you can't use AI for anything. I actually got a job rec sent to me today, an email where it said, this company will not allow AI to be used for any code generation. You have to be comfortable with that. In that kind of environment, they're going to be hiring lots of coders because that's how they're going to get things written. And so those environments are going to be conducive to junior engineers thriving and prospering. So I think it's going to be very dependent, right, on where they get planted. But beyond that, I would say that we need to think about how we are training new engineers, and we need them still, how we're training them to think differently, to approach what they're doing differently, and not just be scripters and coders, right? To have really good skills in terms of critical thinking, problem solving. I don't just mean algorithms, right? I don't know when the last time is I wrote a sort. I'm sorry. I don't write binary trees every other day. I kind of don't need to know that. It's all there already, right? But problem solving in terms of how do I break down a problem? How do I diagnose a problem? Maybe using the scientific method to have a hypothesis and then generate possibilities and figure out how to test those possibilities to disconfirm the hypothesis, right? That's how the scientific method works. We train them, kind of cross-train them in those disciplines so that they come out as thinkers, as problem solvers. Then they're not just coders, and they have value because now they're actually solving problems. That's what I think. We've done a horrible job, in my opinion, of doing that as an industry. Horrible job. We don't expect our senior engineers to mentor the junior engineers anywhere I've ever been. Right? I always felt it was my job to do it, and I try to do it on my own team and others. I try to do that every chance I have, because I think that that's a really essential part of passing on what we learned, right, to the next generation. And so that would be my call to all of us here, is that if we think that's a problem, and there's lots of people who say junior engineer problem is a big one, me included, because we're creating this potentially 10-year bubble in our pipeline of engineers where we're going to run out of senior engineers because all of us are going to retire and there'll be nobody to take our place. And I feel it's part of my responsibility to help solve that. Yeah. I hope not. I hope not. Yeah, it's long been a criticism of higher institutions that they, first of all, they train people what to think, not how to think, and secondarily that they don't really prepare them for entry into the workforce with any useful skills. You're true about that. I used to have bookcases full of books that I only had read partially because I needed to figure something out. Now I've got it all electronically. It's the same problem. It's the same problem. I could spend thousands of dollars. I could spend my entire salary buying books every year and not keep up, right? So your point's true, and but I think that's where we get to have an opportunity to lean on each other, and that's another thing is that these junior engineers that are coming up are learning some things that maybe we didn't get exposed to. I remember when I was at BMRU, we had a young lady come in. She as an intern from one of the local colleges, and she had taken a course in object-oriented patterns, which was brand new to us. We were just figuring this stuff out. She had already had a course in that, and so she came in not just learning from us, but it was something to teach us, right? That she had learned, and so we need to recognize that good ideas, strong knowledge can come from anywhere. It doesn't matter whether you have 0 years of experience or 40 years of experience, right? You have life experience as a human, and you probably picked up something along the way that somebody else could benefit from. There's actually a whole comedy bit about that I won't go into, but exactly, which is great. I mean, we love that. People who want to learn love that, right? Because then that's how you get exposed to new things. If you put yourself in a place where you're always the one that has all the knowledge, then you never learn anything. So we have to be open to those possibilities and help people find a role where they can contribute regardless of what they have behind them. Yep, yep. Ugh. No, actually, no. I mean, I actually I had something about that early on in the early deck of this, and I had like 20 different job titles that were emerging job titles for automation engineers and quality analysts, test architects, whatever you want to call it, these roles. But there was a large number of roles that exist today, right, and may be filled by half a dozen of them may be filled by one person. But as my impression is as this accelerates, those roles become more important. We'll need more of those people filling those roles. And there are new roles that are opening up. I mean, there are all a whole new roles regarding when you're embedding AI in a product, not just using it to help generate the product, but actually embedding it in a product. What kind of testing do you need there? What kind of analysts do you need there, right? And that's a whole other issue because the AI is probabilistic. And so the deterministic kind of test we write today, I give you a 2 and a 1, and you give me a 3 back, right? That doesn't work with AI because it's not going to give you the same answer every time. And you have to figure out how to test around that to say, well, that's in the realm of the answer that I wanted. So the testing becomes fuzzier too. That's going to be a whole different mindset, I think we're probably way over time, but I really, You can bring it on, bring it on. Sure. I don't know how much tooling is around that right now. That's not something I was diving into. I can give you an experience related to that. At Spectrum, they had a team that was doing penetration testing. They had covered what was basically a rampant BOLA violation, broken object level access violation across a suite of microservices. And they wanted, obviously, the development team wanted to address that. They came up with a strategy. They were going to build this verification engine into a library that they put into every microservice that rolled out, right? Not a horrible idea, but maybe not the best, right? So I was looking at it as a test architect, and I was looking at their strategy, and I'm thinking, I know I've heard about other ways of approaching this. I know, for example, we're using Istio as ingress. I know Istio has a hook to an external authorization service, right? What could that do for us? If we changed our approach, how would that help us? And so I used Gemini, right? And I set up the problem to it. I described our environment. I didn't give it any specifics about the company or the application, but just generally what the problem was, and asked it, well, here are two options. Maybe there are more. I want you to find out if there are other more options. And then along as many axes as you can think of, including testability, tell me what the pros and cons of each of those options are. Score them on a 0 to 5 metric. Roll it down to a recommendation, right? And I'm not going to talk about if my option was better, but there was an option that was even better than mine. And so that's one way that we can bring that to bear. Is people have been solving these problems for years. We're not the first ones to have the problem. And the likelihood is the AI has been trained on that material. And at least it can help us work in the direction of better solutions. If it gets down to actually something like generating tests for, let's say I have an API, it takes, identifiers on a path and the headers and maybe a request body, right? And I want the AI to look at my open API spec and generate tests in some form. Let's just say they're curls. Generate curls that I can run against my API, determine whether, as I vary those identifiers, does it let me get access to that data or not? Okay. There's a lot there in terms of the background, but I basically want to generate tests for me. That gets back to what have I put into the process to expect to be able to get that out. Because if I haven't put the knowledge into the process, then I can't expect that. I need to have, let's say, at least to the extent of, let's say, providing a semantic layer on top of my API doc, right? Help it understand what these identifiers are, what the potential values are, right? Provide examples of valid requests and responses so they can model what a request and response would look like. If I haven't defined those requests and responses as anything more than an object in my spec, what am I going to get? I'm going to get garbage. So it all comes back, that part of it comes back to how much have I put into the process to set myself up for success. It's not magic. I mean, we all know that. We know it's not magic. It sometimes appears to be magic because anything that is significantly complex enough appears to be magic to the uninitiated, right? But we know it's not. And so we need to be the ones also as sentinels of truth, helping to other people, including our supervisors, our managers, our VPs, all the way up to top, the CIO and the CTO understand it's not magic. You just can't flip the switch and expect good stuff to pour out of it. It takes work to get there, and then help them define what that work is so we can help set ourselves and them up for success. That's how I see that anyway. All right. Thank you again. Appreciate everyone coming tonight.
All right, so I believe we do have Ted. Bruce, are you still with us? Let's see if we get anybody. You can drop your, actually, no, if you don't mind. I'm gonna pull up those slides, yeah. Yeah, the intro slides. I put the emoji, yeah, perfect. Put the emoji. Thank you, sir. There we go. Oh, that there.